Yeah. Comes on everyone. Let's start off. So the last thing that we did was this force between charges and stuff. Others, do keep your cams on. So let's start off with the problem.
Good evening, sir.
Yeah, chalo, cams on everyone. So we have mass m, charge q. This is also mass m and charge q, and this is some angle theta. So length, okay, this is 60 degrees and this is 60 degrees and this is vacuum. And gravity is there. And then what happened? The whole setup is immersed in a liquid. And these angles became 30 degrees. Rho L is the density of the liquid. Epsilon r is the dielectric constant. Find density of the bob. Let's get this. Any answers? How do we start this? Just start with an FBD. So if you look at the forces here, mg, the repulsion force, this was 60. Tan 60 is F by mg, where F is nothing but kq square by the distance between them, which is 2L sine 60 ka square. Here the forces are the repulsion, let's call it F dash, mg, the bind force. Yeah, tension is also there. This angle is 30 degrees. Tan 30 is F dash minus mg minus bind force. So here F dash is k q square by 2L sine 30 ka square by 1 by epsilon r times. The force becomes 1 by epsilon r. Right, Anusha, that looks right. So let's see. So there we have equation 1 and equation 2, divide them. Tan 60 by tan 30. So this is kq square sine 60 is root 3 by 2, 2 will cancel. That is 3L square by mg. Mg is nothing but density of the body, volume into g, by kq square. Sine 30 is half, so that is L square. Epsilon r. This is rho v minus rho liquid into volume into g. kq square, L square, volume g. Tan 60 is root 3 and this guy is 3. That is rho b minus rho L epsilon r by 3 rho b. The 9 rho b is rho b minus rho L into epsilon r. So rho b will be
When
epsilon.
you take epsilon r, that is like
Uh,
F vacuum upon epsilon r ना आपने F dash जो लिया है अगर आप
uh,
vacuum upon epsilon r लोगे तो 12 sin 30 नहीं होगा ना
uh,
because F in vacuum is kq square by 12 sin 60 whole square.
क्या बात कर रहे हैं?
Vacuum
Think about what you said.
अच्छा एयर में रखा है इट्स नॉट vacuum ठीक
नहीं, एयर का बात ही नहीं है. You kept it in some medium, right?
वैक्यूम सर आपने वैक्यूम लिखा है
यहाँ पे वैक्यूम लिखा,
हाँ सो
तो
मीडियम
यहाँ पे मीडियम था.
तो जो वैक्यूम में वैल्यू आ रही है दैट डिवाइडेड बाय एप्सिलॉन आर ना
हाँ, you're right. But in that vacuum, what distance will you take? Drunkard. If you have two charges, Q and Q, if the distance is R, if the force is F, if you put them in a medium with the same distance, then the force would be F by epsilon R. अगर तो distance को change कर लिया R dash, then the force is the force vacuum force in R dash by K.
ओके मेक सेंस हाँ सर ठीक है जाने दो
happens when you just wake up, you feel like drunkard. So that's it. Then yeah, हो गया. Just solve कर लेना. You'll get the answer from there. Clear? Easy. So epsilon r, if I had given you some value, would have got some numbers, I guess. Maybe I could have taken epsilon r as 3. That would have given you something good. But I hope you got the steps. So basically, ये distance का vacuum force by r ना रे. Got it now. Should not take that initial value. Clear? Easy? Anyone not convinced with anything else, please ask. Going ahead. Now, Artika, clear with this? Neil, Palaksh, Kush, clear with this? Ali? Next one. We have two charges, Q1, Q2. Okay. Now what you did, let's say, there are multiple cases actually. So let's say plus Q1 plus Q2. Now you kept a dielectric slab between them. So initially force between them is F. F is the force on each charge. Now what you did, the same thing, Q1, Q2, same distance. You went and brought a dielectric slab, dielectric constant epsilon r. You kept the dielectric slab here. Suppose if this is plus Q1 and minus Q2. And let's say this time the force of attraction is F inside. Again, you did the same thing, Q1. Again, you're not messing up the distance. You kept a dielectric slab in the middle. You kept a dielectric slab here. So the question is, in which case the force increases, and in which case the force decreases, or in which case the force remains the same. Are you getting what I did? So I'm comparing with this situation. Are you getting it? So initially force is F. If I do this, will the force increase or decrease? If I do this, will the force increase or decrease? So you're comparing the two different problems. So I'm comparing in the two different cases. If I keep the dielectric slab in the middle, if I keep the dielectric slab on the outside, will the force increase or decrease? So in which case, force on each charge. Again, I'm not asking force between charges, that will not change. Increase, decrease, remain same. Now, one thing I'll just remind you, don't use the formula 1 by epsilon r into F vacuum. That doesn't work. Why? You can't say force becomes 1 by epsilon r. Why? Because God said so. No. Why?
The medium must be till infinity, no?
The whole thing should be in medium, remember? So you're just keeping a slab though, that will not be valid. Right, Saina, Hanusha, you guys got it. Got an answer, type in the chat box, right? Let others also try. And it's a good strategy to make sure others don't learn, but we should give a chance for others. In IIT, we call it relative grading. When your friend calls you at evening 7 o'clock and asks you, preparation कैसा चल रहा है? अरे कुछ भी नहीं किया रे. He calls you at 10 and asks you, कैसा है? पता नहीं रे क्या करेंगे देखते हैं ना कल. Next day morning exam, you write the full paper and submit and you score 95 and your friend fails. And then he asks you, तो preparation तो नहीं किया ना? अरे मैं सिर्फ 3 आंसर पढ़ा तो वो 3 एग्जैक्ट ला गया पता है? You have a friend like that? You'll have. Let's get this thing. Who is missing? Someone is missing. The advanced paper is online, on SHM till Saturday night 11. Make sure to give. Decreases on both, increases on both. Okay. Should I show you? I'll give you another 30 seconds. Figure it out.
1 minute.
Yeah. Rehan, adjust your cam. Lakshika, Maulika. Make sure your faces are visible on the screen, everyone. I know you guys have good haircut, but let's make sure we can see your faces. See. So in this case, let's see how will the charges distribute, okay? Because of this plus Q1, you will get a minus here. You will get a minus here. So the plus should somewhere, lie in the surface. So the plus will be in the middle and the minuses will be closer. So what will happen here? The Q1, Q2 are already repelling. Now the induced will attract here. So on both of them, force decreases. Now in this scenario, this guy would be minus, this guy would be plus. Now both are already repelling. Now this minus is closer, so this guy will attract. This guy will attract. So this guy force will decrease. This guy force will increase.
तो सर आपने दो सब पार्ट दिए थे भाई के आई जस्ट सॉ
मतलब हाँ ना, एक क्वेश्चन का दो पार्ट था.
ओह आई जस्ट आंसर्ड द फर्स्ट फॉर बोथ
ठीक है ना, कर लेना, उसमें क्या अभी वापस. आई एम गिविंग यू टाइम फॉर द नेक्स्ट वन. बट गॉट इट ना, व्हाट आई एम आस्किंग नाउ, यू गॉट इट राइट.
यस सर
देयर इज नो गारंटी लाइक दोनों में इंक्रीज होना है, दोनों में डिक्रीज होना है. यू कैन मैस इट अप. क्लियर. नाउ कैन यू ट्राई द सेकंड पार्ट. ट्राई, आई विल गिव यू अ मिनट. I'll draw a better diagram. Wait. Q1 minus Q2. So blindly don't remember always like the force will decrease. The entire thing should be medium. You can play like this also. Hmm. Okay. Let's see. Even I don't remember the answer. So in this guy, they are already attracting. Now he will induce minus here. This is plus. So this guy is closer, so this will attract. This guy is closer, this will attract. So both increase. This is plus. Why? Minus is more closer than plus. So minus charge will dominate. Again, we are assuming the slab is pretty close to minus Q2, okay? If you say, sir, what if I keep this far? Iska field bhi zyada ho sakta hai. Yeah, all those things are possible, but we are assuming it is pretty close. So I'll just add this. Slabs are very close. So if I kept it so close, Q2 will dominate. So can think of like that. So this guy will attract, this guy will attract. This induced charge will attract. this induced charge will repel. Both are decreasing, right? Check. Easy. Conceptual. So nothing there. Matlab, there's no numerical, nothing there. Just you have to figure it out. Right, Arjun? Anusha. Sign off. Next one. So great. That is about the force. So, whenever people are working on theories, right, they always have a problem. You see something and you need something to explain it. So the same thing here, we observed if there are two charges, they attract or repel. So that is great. But then people had a problem. How does one charge know that there's another charge somewhere else? You're getting it? How does, if you bring a charge Q1 and if you have a charge Q2 there, how does Q1 know that Q2 exists? And how do you explain this? No, it is always that way. See, your explanation might not be the right thing, but people always have a tendency, right, to create theories to explain. Your best thing, if you see in chemistry, atomic structure, what is the first theory? The J.J. Thomson model, the watermelon model. He said the nucleus is like a watermelon, electrons are embedded inside. Then came Rutherford. He said, nay, nay, it's a planetary model. Then Bohr came and said, nay, 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 you can't have an electron going in any orbit. Then you lose energy and collapse. So there are some specific orbits where angular momentum is quantized. Then came Sommerfeld. He said, nay, nay, it is elliptical orbits. Then came this guy who is that? Yeah, Schrodinger. He said, yeah, there's no electron only. It is a wave function. Did you see how the theory evolved? So from the point to say there's an electron, now we simply there's a probability wave function. So that is the thing with the science. You keep explaining, keep creating theories. As long as it works, it grades. The day it doesn't work, you grade anyone. So same thing. So these people created a theory which is pretty interesting. This is the same thing we are going to use for gravitation, magnetism, and all that stuff. We call it field theory. Now, this is completely hypothetical. What you see in real life is force. You explain that with the field, but the textbooks will write as if field came first, and that's the reason you're getting force. You're getting it is always like that. It's like, you arguing with your parents. Your parents say you are born because of, us. And you arguing because I was born, you became parents. Right? Statement makes sense. But then your mom is definitely going to throw a chappal or, something on you. It happens. So a field theory is what? A body modifies its surroundings by creating field lines. So this is a completely hypothetical concept. But like I said, it works pretty well. And when another body enters this region, they interact. So maybe the inspiration was so this was hypothetical. So think of like this, if you ever seen a spider ka web, the spider ka web is like this. Spider is sitting here. If you see an insect comes and hits here, the vibrations travel through the web, and that's how the spider knows, which side to go and walk. That is how a spider hunts. It just makes a big web and sits in the center. When something comes and hits a web, the vibrations travel in that particular string, and that's how this thing knows I have to go there and catch it. So something like that sort. So here, whenever you have a positive charge and when you have a negative charge, so these things, what they're doing, they're just emitting a field lines, kind of like a spider web. So a positive charge will emit field lines outside. A negative charge will absorb field lines. So, and if you bring another charge into this region, that is how they interact. So that is how they came up with a concept like. So let's say some properties of the field lines. Now, so that is how one charge knows that there is one more charge somewhere else. That's how they interact. Turn in the page. Now the properties of field lines. So let's see the properties of these things. These things are also called the lines of force. So the first property is, like I said, it's a artificially created one. So people made it up. The positive charge emits field lines. So basically, this indicates the repulsion ka nature there. The lines are going away types. At negative charge, the field lines converge. The number of lines is proportional to the charge. Now you should be like, how do you know how many lines will be there? That's what I said. It is imaginary. There is no number of lines. So it is always artificial. Example, if you say there's a charge Q1 and let's say there's a charge minus Q2. This is a good question actually in even a mains level. Mein. Let's say there are field lines like this. So they'll ask you find Q1 by Q2. What is the answer?
12/8.
So what we do here, we count. So if you count them, this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. This guy has 1, 2, 3, 4, 5, 6, 7, 8. So Q1 has 12 lines. Q2 has 8 lines, but we'll put a minus because they're coming towards it. So that ratio would be minus 3 by 2. So how do you know how many lines are there? We don't know. So what you do, you have to give me some reference. If you say a charge Q has 20 lines, and if you put 2Q charge, I will draw 40 lines. So it is all relative. So there is nothing like, itna hi lines hona chahiye. If you ever seen a map, right, on an A4 sheet, remember it will be written 1 centimeter is 200 kilometers. So it is a scaling factor. So same way, what if you have a very big sheet? If you have a very big sheet, then you can write maybe 1 centimeter is 10 kilometers. So depending on how big the map you have, you can have a different scaling factor. So the same way, I can draw more fine lines. Matlab, if I draw 24 lines here, I have to draw here 16 lines. That ratio will be always maintained. The number of lines will not be same. So number of lines per unit charge is actually arbitrary. Number of lines per a given charge is arbitrary. You can choose anything and use that as a reference. That is, we can choose, let's say, 1,000 lines for 1 coulomb. Then 2 coulomb will have 2,000 lines. Or if we choose 10 power 5 lines, so 1 lakh lines for 1 coulomb, then 2 coulomb should have 2 lakh lines. That's it. That is the only comparison. That ratio will be maintained. Clear? Can I turn the page? Now on this, I can ask you one more question. What if, this is also actually a good question. You bring a charge plus Q, you keep it in front of an inductor and some material, and we know there's some charge induced. This is minus Q and this is plus Q. How can you compare plus Q and minus Q? Which is bigger, which is smaller? Let's say we bring it in front of a conductor. The question is compare Q and minus Q. Which one is greater? The magnitude. Meaning if I bring, let's say, 1 coulomb charge, will I induce 1 coulomb? Will I induce more than 1 coulomb or less than 1 coulomb? At least in this scenario. It does vary a bit, but we'll see that in Gauss law. But in this scenario, equal. Okay. You guys have a proof. Don't tell me your feelings. Feelings are bad. We are not running an astrology class here. You need to have a proof because you won't have guts, to mark the same answer in the final exam. Will you do that? Because of your feeling? Then don't answer. As simple as that. That is how you should learn to think. Because kya hota hai na? If you are very loose with your answers while studying, you will do the same thing in the exam also. So you should always ask yourself, whatever I said right now, will I have the guts to mark the answer if this in the final exam? If you say yes, I think then you're fine. But if you say no, then I think that then the way you're preparing is wrong. कंडक्टर पे नेट 40 करेंगे उससे कुछ फायदा नहीं है रे. Conductor should be neutral, less fines and less field lines converge. Anusha, that looks little right. So see, if you try to draw the field lines, what will happen? Some field lines will go here. We will see later on why it is perpendicular. That anyway doesn't affect our problem. So, but some lines are going to infinity also. And some lines are coming out from here. Normally, this is how the distribution will look like. Did you notice something? Every line that minus Q gets is from plus Q. Every line the minus Q gets is from plus Q. You can't get lines from anywhere else. But plus Q ka some lines are already going to infinity. So the total number of lines the plus Q has is greater than the number of lines minus Q has. You're getting it? So now you can ask me, sir, iska minus Q ka while lines are not coming from infinity. Tell me one thing. Who is creating minus Q? The plus Q. So the plus Q is responsible for the minus Q. So every line that you got must be due to plus Q only. All field lines of minus Q start from plus Q because there's even a better explanations, but we will see that later on. But for now, I think this is a decent, fine explanation. Since plus Q is responsible for inducing charge. And you can clearly see number of lines of plus Q is greater than number of lines of minus Q. So you can be sure the Q is greater than small q. Can you have a line like this? A line starting from this plus and leaving at this minus. And that is not possible, but we'll see later on why. I think right now I can't explain that if you don't know about the relation between field and potential. Since it's a conductor, it should have same potential. So if you go from here and come back here, the work done should be 0. But if there's a field line, there'll be some work done. So there's an explanation like that. We'll see later on. Clear with this point? So this is a good question actually. The next thing, the electric field strength. The electric field is tangential to the field lines. That means you have a field line At every instant, the field will be tangential. So if this is point A and this is point B, the number of lines per unit area gives you the field strength. Something similar to the streamlines actually. There is the number of field lines per unit area gives you the flow. That means in this case, the magnitude of A is greater than magnitude of B. So basically, if you have more field lines, you'll get more force. So what is the difference between let's say I ask a question like this. A charge Q is placed on a streamline, a charge Q is placed on a field line. What will happen? Let me show you the question. Is this page clear, everyone? Can I turn it? Going ahead. Aditya, Adrit, can I go ahead? Yeah, so let's say the question is like this. You have some field lines. You have streamlines. Now you kept a charge on top of it. So you kept a particle here, and let's say you kept a charge here. What happens? There'll be four statements and they'll expect you to tell it, but I won't give options. You guys tell me what will happen. If you put a plus Q charge and if you put a particle on a streamline, what happens? Let's see for streamline definition. What is the definition of a streamline? It is a path of the particle, isn't it? So this guy will simply follow the line. Particle moves along the streamline because there's a path of the particle. That is the definition of this thing. This is the path of the particles. What about a field line then? It won't follow the line because of inertia. Yeah, but little more explanation. Exactly what happens. What's the difference between the field line and this thing? In the field line gives you the force. So that means the moment you keep the charge on it, the particle is pushed away tangentially. So the force will be this way. And then what will happen? This will go and enter this line. Now the velocity is this way, but the force is this way. You're getting it? So it just keeps getting pushed at a weird angle. Maybe I should draw a little bigger diagram. So the moment you keep a plus Q charge here, this is the force car direction, the tangent. So the path will go like this. It's not exactly accurate, there'll be lines in the middle also, but I'm just trying to show you. So this will try to go in a straight line. Once you reach here, now this here the force is this way, but you have already acquired some velocity this way. So now you start going somewhere in the middle like this. So basically you'll start curving at every point. Now your force is this way, but now you have a velocity somewhat in this direction. So now you'll start going somewhere in this thing like this. So it goes in a curve. So every time it reaches that, the particle is pushed away tangentially. So it's not the path of the particle. Getting the difference? So it won't follow the streamline. How to make it follow the field lines? Make the field straight lines, no? If the lines are straight, yeah, right. That is the only time when it will go in a straight line. If you make the curved lines, it will get messed up. But streamlines don't care. Even if a streamline is curved, it will follow the path. I hope you're getting the difference between the definition of streamlines and field lines. Fourth, two field lines never intersect.
Sir, could you show the
Simple.
previous page for a moment?
Previous page here.
Sorry.
This is a simple thing because if two field lines intersect at the point of intersection, we'll have two directions, which is undefined. Fifth, field length propagate with the speed of light. What do you mean by that? The meaning of that is, think of like this. It's not exactly electric field, but gravitational field also follows the same thing. If let's say sun suddenly vanishes, what happens to Earth?
After
What happens
8
to Earth?
realize कि sun नहीं है.
It takes time. Immediately we won't realize. So I'll turn the page. Type your answers, Reshan. Type your answers.
Oh yeah, sorry.
Let others also try. The moment you tell the answer, now others will stop thinking. So if you have a sun here, now normally, right, it takes around, light takes 500 seconds. That is 8 minutes, 20 seconds, blah, blah, blah. Getting it? So if you have an Earth here, so that means right now, when you go out and see the sunset, the sun has actually gone back 500 seconds back. What you're seeing is delayed. So every time you go into the night and see the stars, what you're looking at is the past. The nearest star we have is Alpha Centauri, which is 4.2 light years away after the sun. So that means whenever you see that star, you're seeing the position of the star 4.2 years back. So every time you look into the sky, you're seeing the past. None of the stars are there in that respective positions. Everything has moved away long back. So this thing will take around 500 seconds. Now, if sun suddenly vanishes, so that means the gravity we are experiencing right now was released 500 seconds back. If sun suddenly vanishes, some reason, Earth will continue to go in a circle for 500 seconds. Earth maybe will not notice anything. We'll have light, we'll have everything, right? Earth will continue in a circle for 500 seconds and then will fly off tangentially. So basically, it will take us 500 seconds to realize that sun vanished. So immediately it won't go off. So the same way charges also behave. So if you bring a charge and keep it at a distance of 3 lakh kilometers, the speed of light is 3 lakh kilometers per second. So it will take 1 second for the other charge to realize that this charge suddenly came into the picture. So this guy will go in a curve and then it will fly off. Meaning till here, you're still, the gravity is still reaching. The lines are ending, done. And once that ends, it goes off. Nothing. There's no way to realize that because nothing can travel faster than speed of light in vacuum. Clear with the statements, everyone. All these things are valid even for gravitation also. But unfortunately, when Newton proposed this theory, right, he didn't have this idea there. Newton thought gravity travels with infinite speed. That means the moment you put a mass there, the other mass somewhere at infinite space will know this. But he knew something was wrong. He knew something was wrong, but like again, he was too advanced for his times. He couldn't figure out what the hell was happening exactly. Meaning, how did he know it was wrong? He couldn't explain Mars' orbit. If you take Sun and if you take Mars name, Mercury, the Mercury is so close to the Sun, it actually goes in a kind of an ellipse. That is still okay. He was fine with it. But the problem is this ellipse itself started rotating. The ellipse itself is not fixed. That ellipse will keep on rotating. So a Mercury is going in an elliptical orbit, which the elliptical orbit itself is rotating. You can't explain this if the speed of the gravity is infinite. But you can explain this if the speed of gravity has a delay. If the Mercury has some, because it is too close, the effect becomes very prominent. Now, how did he prove that and all? Now, that's a different thing there. But he knew something was wrong, but he couldn't figure out what it was. So he just kept it as that infinite speed and stuff. That was another drawback of Newton's law of gravity. But okay, clear with this. So this is all theory part. So let's see exactly what do we call by field. Now, don't get confused by what is field and all. Field is same as force. Can I turn the page? Aryan, go ahead. Yeah. So this is how we define field. So electric field E bar. So the simple definition is the net electric force per unit charge. Now, by now you must have understood this one thing. In science, right, we are always obsessed with per unit. For example, remember in elasticity when we studied, we are not studying force and elongation. We are studying force per unit area stress. We are studying elongation per unit length strain. In fluid mechanics, we studied mass per unit volume density. Getting it? So because when you study something per unit, it becomes more easy to scale it up. Just think of like this. Let's say I'm selling apples. I buy an apple for 90 rupees and I sell an apple for 100 rupees. Now, if I sell 5 apples, what is the profit? 50. If I sell 22 apples, what is the profit? 220. If I sell 32 apples, sir, you'll say, sir, stop. Sir, per apple, you make 10 rupees ka profit. How many apples you bring, simply multiply, na? You're getting it? So instead of defining how many apples I'm going to bring, how many I'm going to sell, you just define your profit as boss. Per apple, you make a 10 rupees profit. Whatever you bring, you multiply with that and done. So if you ask me, sir, what is the difference between field and force? Anytime when you get confused between field and force, there is no difference. Both are one and exactly same. It is basically field is nothing but force on one unit charge is called field. Clear? And this thing, right? We humans always has obsession with this per unit. It's a valid thing because I think I asked you this once. One time, I was having a discussion with one of my relative, and the topic was like, "What do you think about money?" So he said, "Arun, is money important in life?" What do you guys think? Is money important in life? Money is not important in life. I told him, money is not important in life. What is important in life is what? Money per unit time. Meaning, think of like this. Let's say, I ask you guys this thing. Let's say I will give you 1 crore in next 100 years. Are you happy? Next 1 year, thoda happy. Next 1 week, more happy. Now, what is the difference then? If it is the same 1 crore, why didn't it make you happy in 100 years? Why suddenly the happiness became 1 year to 1 week you're more happy? So you're not actually interested in money. It was never that money that you're interested in. It always you're interested in money per unit time. Problem humans don't have, we are limited lifespan. Let's say if I tell you like I'm going to give you 1 lakh crores in next 1,000 years, does it make any sense for you? I say like, what the hell will I do? I don't exist only. So it is not money that is actually making you happy. People don't realize this. It is money per unit time. Right? Right. So these kind of all nonsense topics, right? One day before the exam in IIT, you sit at 3 o'clock on the terrace and discuss with your friends because कल तो exam को पढ़ाई नहीं करना है. So we talk about philosophy and all these kind of great things. It might make sense, but if you had talked about it when you're free, but नहीं, कल exam में पढ़ाई नहीं करने, now we sit and think, what is this exam? What is this life? क्या चल रहा है? IIT में हम आके कर क्या रहे हैं exactly? Right? ये सब exams करने के लिए आ रहे हैं क्या? Then next day you go to the exam and mess it up, and that day night you sit and you promise yourself, next exam ना 1 week पहले सब preparation खत्म करके ना मैं दिखाता हूँ what I am करके. And then again one day before the exam you do the same thing. So it doesn't change. Just because you go to IIT doesn't mean you'll change as a person. You'll still do the same shit, but at a higher level. You don't study anything. I know, right? Even I used to do that. We used to start studying at night, 8 o'clock. Next day, exam morning, 8 o'clock. Full night out, huh? 4 hour preparation, 6 months ka course, you finish off in the 10 hours. And then before going to the exam, you take bath, brush it up, and drink 2 coffees and go to the exam so that you don't sleep. 8 to 11 is the exam. By 10:30, you're already gone. Your brain is floating somewhere. So you have to finish the exam in 2 hours. So you'll find. So this is the thing. So if you have a charge Q here, and if there is a point P here, so if you want to find the field at point P, so if you bring a Q charge here, I will not write all proper definition at all, we got the point. So we'll put actually Q is very, very small, Q tending to 0, since remember what we said, every charge will emit its own field line. So we don't want it to come and mess up the field lines of this plus Q, so that it does not interfere with field of Q. This is actually another very important thing in science also, Heisenberg uncertainty principle. If you try to figure out your momentum, you mess up the position. If you mess up the position and this thing, but put it in simple words, right? The very act of observing something messes up your observation. The very act of observing something, you mess up the observation. For example, let's say you and your friend, right, are talking and and trying to say some bad things about me. अरे वरुण सर ना वो ऐसा है, पता है वो इतना weird है, वो है ये है. And then I'm just passing by. अरे but sir बहुत अच्छा है, पता है. You see, the moment I pass by, the very act of me trying to observe what are you talking about me will change the way you talk about me. Ever happened? Your friend is there and you're bitching about your friend. And then your friend comes walking, then you keep quiet and then you say like, "Nee re, acha hai, sab theek hai, good, good, good." See, you messed up the very observation you wanted to observe. So there's an observation like this, simple questions like there was one Australian scientist, these people are trying to study how long does the fish live. Now, the problem is, if you leave the fish in a river and try to study, it will run away. You can't study. But if you put the fish in an aquarium, it will live longer, maybe because you took care of it. So you'll never know exactly how long a fish will live. So yeah, works out. Getting placement similar to cracking JEE. Yeah, placements is completely different. Placements are like school only. You should get decent grades. You should have decent contacts. You should go and talk well. Yeah, it is fun. I too don't know actually. I never sat for placements, so I was clear I want to be a teacher. So I did attend for placements. Fiji का interview गया था मैंने. So 2010 में Fiji was the only institute who was taking placements and all. So I went to write the exam. So there were 5 exams. Morning 8 o'clock का exam था, 8 to 9. They'll give you 20 questions, 3 marks each. And then 9:30 to 10:30 subject to paper. You have to write down. Again 20, 60 marks, 60 marks. I think I scored 40, 42 something. I was third in the class. Highest was 60, 60. That guy was 10, 15 years experience that time. मैं तो बच्चा था actually. 2010 just came out of the college. And then after that, there was a group discussion. They gave some random topic and everyone is shouting. I said, okay, I waited till the end and then I also shouted 2 points and left it. I understood it was meaningless anyway. If you're a teacher, what is there to discuss? There's no group discussion in a class. And the third was, कुछ तो था, HR round. It was a demo. I have to go and teach one topic. So I took fluid mechanics. I started teaching, I forgot something in the middle. And then He said, "What about this?" I said, "I forgot." He said, "Good. At least you accepted it." That is one of the thing. You don't know, it is fine, but learn and don't mess up the, learn and next time teach it properly. Don't mess up the student career. If it is wrong, it is wrong. What is wrong with that? Accepting it. But anyway, I was a kid, so he was fine with it. Then fourth, there was an interview. Then he asked, Arun, I was looking at your grades, they were little less. What happened exactly? And then I said, yeah, I told him, like, see, after second year, right, I really didn't feel like the courses were not up to my liking. So I really didn't give much. I just wanted to finish it off. But I did all other interesting things. He said, what did you do exactly with your time? I said, I'm a computer gamer, right? I had two teams. So I went for many competitions. I won. It was very fun organizing and planning everything and all. He was looking at me. I said, what is your favorite thing to do? I said, I like to sleep. Right. And so that guy, there were three people interviewing. The other two were looking at me like, यार ये क्या बात कर रहे हैं मतलब? And I was very proud of it. I said, like, I was telling very proudly, matlab nothing hiding. I said, I'm a gamer. I play a lot. I have two teams, right? I learned violin. I learned martial arts for 2 years. I did a course on filmmaking. I did a course on how to write books. I'm a hostel runner. Every Saturday, Sunday, I used to go and do, part-time job. I used to earn my own money. I paid my entire college fees on my own. Only first semester, I took some 30,000 from my parents, and remaining 7 semesters, I paid my own fees. I
Then
never took a loan. So,
how did you pay your own fees?
Saturday, Sunday, I used to work every Saturday, Sunday, 6 hours. They used to pay me 300 rupees per hour in the beginning. Then they used to pay me 500 rupees per hour.
Child? Oh wait, you were above 18, never mind.
पार्ट टाइम जॉब ना आईटी में तो अच्छा होता था आईटीएंस को तो बहुत डिमांड था चेन्नई में सो हो गया देन दिस गाय इन द मिडल ना देन दिस गाय सेड डू यू नो हु आई एम ही वाज एक्चुअली द फिजी का चेन्नई का फिजिक्स एचओडी देन आई सेड आई नो सर योर एच एन बॉन्ड he was also a then he said how do you know my name I said sir we have seen your games he was also a gamer I said तो when I was going to the interview ना मेरे सीनियर्स बोला था अरे एच एन बॉन्ड होगा वहीं पे फिजिक्स इंटरव्यू है ना वो एचओडी है when you meet him ना say hi मतलब my senior का senior था वो so it was 2010 so that guy passed out in 2006 that means the year I entered he already passed out so he worked in Fiji and became a HOD there he was a gamer so we used to look at his games for references कैसा खेलना है strategy क्या है so I told him you're HN1 and that guy was shocked I said how do you know me I said sir we still see your games in the IITs we learned a lot of things from you and that guy अरे अभी भी खेल रहे हैं क्या suddenly this guy became normal huh? We started talking हाँ सर अभी भी खेल रहे हैं but you know आजकल Warcraft थोड़ा ज्यादा हो गया सर Dota खेल रहे हाँ अरे मेरा टाइम पे भी स्टार्ट हुआ था and we both are talking about games and the other two are looking at us मतलब क्या चल रहा है यार इंटरव्यू है यार we just talked for 5 minutes he was so happy and then he looked at the other two and said okay okay let's get back मुझे आइडिया आ गया था हो गया मैं सेलेक्ट तो हो गया अभी इतना कुछ डाउट ही नहीं है आई न्यू ही वाज एच एन बॉन्ड तो वही था थोड़ा वो भी कॉन्फिडेंस इसीलिए आ रहा था and I knew he will ask what did you do and I know I will say I'll do gaming and then he'll ask what game सब प्लान था and it was fun and then by evening हो गया next day morning I got a letter Arun you got selected please report to Delhi in the next 3 months for the training blah 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 so that's a story for some other day next thing so F is equal to kq by r square so we defined the field as force per unit charge so that guy becomes kq by r square so you can take the vector form so r cap is a unit vector depending on the direction, like whether the field lines are going away or they're coming back. So R cap is a unit vector from charge to point P. So simply write, you can also write force is equal to charge into field. This is another way of writing. If someone gives you field and they ask you, this is the field due to a point charge. This is the relation between force and field. So just like force, it's also vector quantity. Basically, it is derived from the same thing. So if you have multiple charges q1, q2, and so on till qn, and if there's a point P here, the net field at point P is the vector sum of the fields due to the individual charges. Have a look at this. Clear? Now, if you try to draw the field lines for the whole thing, let's say if you have a plus q and a minus q, so you'll have somewhat field lines like this. But if you have both plus q and plus q, again, I'm approximately drawing this. So basically, they will push away each other. So you get something called a null point. So when you hear the word null point, meaning the field is zero. Yeah, neutral point, null point, you can call it whatever you want. Clear? Let's say a question. The last one was question 11. We have a charge 4q and we have a charge minus q. Both are fixed. The distance is d between them. Find the null point. One is plus and one is minus. Get this thing. It's a standard equation. A mains level. Try. I'll give you a minute. Distance d minus q to the right. Okay. Right, Anika. Try others. नहीं आदित्य, you goofed up. Check करो. Signs are important, huh? Just ask yourself this way. If I take a point in the middle, what will the 4q do? It will push. What will minus q? It will attract. They can't cancel, na? The point, you cannot have a null point in the middle of them. One is minus and one is plus. They will pull in the same direction. So you have to argue like that. So will the point be here? Will the point be here? Will the point be here? You can't be in the middle because they add up in the same direction. You can't be on the left. Why? Why can't you be here? यहाँ पे तो 4q is pushing and minus q is attracting. So they're opposite. So can you be on the left hand side? Distance matters, right? Because the problem is the 4q is already very strong, and usko upar se you're keeping it so close that magnitude will never be able to cancel minus q ka magnitude. Agreed? So it can't be on the left hand side. So the only possibility you can have a null point is on the right hand side. So we need to, you cannot, right, Adrit? So that is how you argue with that and say the null point should exist on the right side of the system. So if you choose the 3 points here, A, B, and C. So if you see here, this guy is attracting, this guy is attracting, this guy is attracting. So this is minus q, okay? So this 4q guy is pushing, and this is pushing. So at B, you can't have a null point. At A, magnitude of 4q is greater than the field due to 4q is greater than field due to q. So we can't have a null point. So the only way you can have a null point is on the right hand side. So this is 4q. This is minus q. Let this point be p. Let this be x. And let this distance be d. So the 4q ka field will be, remember, k 4q by d plus x whole square. Now you don't write k q by r square. That small q won't be there anymore. You're taking that as a unit charge, and this minus q will attract, so it will be towards the left hand side. K q by x square. Equate them, you will end up with d plus x by x whole square is equal to 4. X is equal to d. Yeah, x is equal to d. So on the right hand side of the distance d, you get it. Check it out. Easy. So be careful. If both are plus and plus, then the null point will be in the middle. You'll get 2 roots for the quadratic, but then 1 root will come x negative, meaning that will be again in the middle. That doesn't work. So we eliminate that other one. All got this thing? Let's see one more. Any doubts on this? Udayan, Palaksh, Vidyut, clear, na? Abhinav, Aryan, Ali, got this? Rehan, clear? Great. So we have a regular hexagon here. Plus q, minus 2q, 3q, minus 4q, plus 5q, minus 6q. Find the field at the center. The field is coming 0 mathematically. Why is the signs not taking care of the signs? Side of the hexagon A. So y पे लेंगे तो क्या आएगा? D plus x. So then you're getting what here? Minus 2x is equal to minus d by. Problem क्या है ना here? What is x? X is actually the distance from the charge. X is not a displacement.
So suppose मैंने अंदर लिया like
नहीं
between
नहीं
x d minus x. Like I don't
नहीं
need
problem.
to use
नहीं and try to understand. What did you write x as? X is the distance from minus q to p. X is not the x coordinate.
ठीक है सर सपोज आई डोंट नो दिस कॉन्सेप्ट एंड आई टुक x like 4q से मैंने x लिया कहीं इंटीरियर पॉइंट पर d minus x from the other side you will still get mathematically somewhere field equal to 0 no और वो
आया क्या?
मैथमेटिकली
कितना आया?
d minus x upon x 2d/3 I think.
दूसरा रूट क्या था?
I neglected.
नहीं, वो लेना. मे बी आई थिंक दैट विल गिव यू दिस आंसर ओनली, आई गेस.
तो ये
So it
बात
was
फिर
minus d by 3, I think.
इफ यू टेक दैट वे, क्या आएगा वो? इट विल बी लाइक d minus x by d will be plus or minus 2 ना?
हाँ, d minus 4kq by x d minus x by x will be equal to 1 plus
x ना, plus or minus 2x.
हम्म
तो अगर प्लस लिया तो you're getting x is equal to d. अगर माइनस लिया you're getting what? नहीं, if you take plus, what are you getting?
d
x
minus
is
x
equal
by
to
x
d
equal
by
to
3.
plus minus 1 by
If
2.
you take d minus x is equal to minus 2x, then what you are getting? Then you're getting minus x is equal to d and x is equal to minus t. तो वही आया ना आंसर. You took x on the left hand side, but x is on the right hand side. So that one root is not valid. Upwards. Okay. हाँ उत्साह, उसमें से एक्चुअली आ रहा है आंसर. व्हाट यू सेइंग?
4q से x d minus x 4kq by x square equal to kq by d minus x square, ये सही है ना?
x कहाँ से लिया तूने?
4q के साइड.
ओके, मैंने x इस साइड से लिया
हम्म
एंड मुझे x इज इक्वल टू माइनस डी आ रहा है, मतलब दैट वे.
एक 2d/3 आ रहा था और एक
That we can't take actually. That result won't work out because we know the directions will add up.
Suppose I don't know, then why isn't the science taking care of it?
वो सोचना पड़ेगा एक्चुअली, मैंने कभी सोचा नहीं.
Okay.
But maybe it was like
Sir, I think because हमने x को उस side लिया, we took the assumption of the field कि वो it is towards the left only, and if you move it inside the field, का direction changes itself. So whatever expression we used, it is only valid for when x is
राइट रे. वो ईशान जो बोल रहे सही बोल रहे. बिकॉज व्हेन यू टुक इन द सेंटर, डायरेक्शन तो एज्यूम कर लिया तो ऑलरेडी.
हाँ ठीक है.
देन तो डायरेक्शन भी एज्यूम नहीं करना चाहिए था.
Then हम कुछ इसमें करते थे ना, like let's say what problems.
नहीं, यहाँ पे प्रॉब्लम क्या हो गया ना, नॉर्मली फ्रिक्शन एंड ऑल उसमें कैसा है ना, द एफ का डायरेक्शन वुड वर्क आउट विद द प्रॉब्लम. बट यहाँ पे क्या हो रहा है ना, द मोमेंट यू चूज द पॉइंट, द डायरेक्शन इज बीइंग फिक्स्ड.
Makes sense.
In NLM में when you see ना, when you take f this way and we start solving the problem, f negative आए तो we'll take it backward. We never had a problem there. But यहाँ पे ऐसा नहीं हो रहा है. The moment you choose it is like this, that itself is affecting the problem.
Okay.
So maybe that is the reason it is not working out. 13th people answer. Heal at the center 2 root 3. क्या करना था उसको? See. So that is you can actually directly finish it off. This guy is what, plus q now? So let's say E is equal to kq by a square. So this guy is E, this guy is 4e, it'll attract. This guy is 6e, and that guy is 3e. This guy is 2e, and this guy is 5e. All are 120 degrees. So basically you have a vector 7e, 9e, and 4e. The bisector 60 degrees and 60 degrees. 5 hoga. So horizontal component will be 7e minus 9 plus 5, 14. Horizontal cancel ho gaya actually. 14e cos 60 I cap, that would be cancelling out. Vertical component is 9e minus 5e sin 60 j cap. That guy is 0. So this is 4e 2 root 3e j cap. Easy? Clear? Next one. Do one thing. Take a break. Come back by 7. We'll continue from here.
Sir, if you have three positive charges on the vertices of an equilateral triangle, then would you want four null points or just one?
एक ही आएगा रे.
वो साइड में क्यों नहीं बनता?
है कैसा बनेगा ट्रंकट? देख, you have a here साइड में कहाँ बनोगे? यहाँ पे. ये दोनों कैंसिल होगा, बट इसका तो फील्ड पुश करेगा ना.
अच्छा.
When you say null point, सब जीरो होना चाहिए रे. दो चार्जेस का नल पॉइंट नहीं निकालना है
ठीक है सर.
ना. व्हाट मी डू थिंक देयर विल बी 3. यू जस्ट कैंसिल टू चार्जेस. वो थर्ड वाला भी लेना पड़ेगा ना. टोटल फील्ड इज जीरो व्हेन यू से नल पॉइंट. बी केयरफुल. एनीथिंग एल्स? चलो, कम बैक इन 10 minutes. Ouch. हाँ ईशान देर
Yes, sir. Here.
तू मैसअप कर रहा है एंगल्स को देखो what you took na 12 sin theta that is this angle you took angle between the strings
Ah, yes, yes, yes. Right. Okay.
तो ये 12 sin theta था दूसरा जो एंगल था ये एंगल अल्फा था
हाँ. So उसके
हाँ,
बाद भी आ जाएगा ना. We can still, I think, form an expression based on it.
पता नहीं अभी वो थीटा और अल्फा का रिलेशन कैसा निकालेंगे
So theta alpha का relation नहीं. We can just take alpha as one angle only, and उसके
ओके
I think we can find
अल्फा से won't get theta
uh so alpha says so we can find also we can find the length of the median now with alpha. I think.
ये अल्फा है
हाँ, we'll get.
from there you will get this चलो from there you will get this you will get a relation between alpha and theta हाँ निकाल सकते हैं
हाँ.
then
And then we can just do what I did. बस expression अलग बनेगा. I think we can still find theta somehow ना and alpha both.
ट्राई करके देखो but you got your mistake ना what you did
Ah, yeah, I'll try it again.
हम्म
Yes.
लग तो रहा है बट आई डोंट नो मतलब कॉम्प्लेक्स हो जाएगी 12 sin theta होगा this should be equal triangle ना that should be 12 sin theta root 3 by 12 sin theta by root 3
हाँ, yes, वो 30 degree होगा. So
और ये L था so that should be sin alpha is 12 sin theta by root 3 by L तो ये रिलेशन था
and we can just put it now. I think.
पता नहीं अभी ट्राई करके देखो लेट्स सी
Sure.
चल कैम्स ऑन एवरीवन now this is important right? The same model again we will see in gravitation we will see in magnetism 3 more chapters so let's see one I'll show you one and then I'll ask you more so we have a x and y axis we have a charge here plus q at minus d comma 0 and we have plus q at d comma 0 so we are trying to plot the electric field on the x-axis versus x coordinate meaning if a person is walking on the x-axis what is the electric field you will see so plot ex versus x coordinate so ex is the electric field on the x-axis if ex is along positive x-axis Take it as positive. That's your convention. That means if the field direction is this way, on the graph, we will draw it as a positive graph. So let me explain you one question. So listen carefully, everyone. So we have two charges and we have a person who is walking from plus infinity to minus infinity on this thing. So I want to plot the graph. So ask yourself, if the person is at infinity, what is the field? At infinity, the field is 0.
Zero.
Okay. Now, when you're on the left-hand side, which charge will dominate?
Plus Q wala.
Plus Q.
So let me write this as plus Q with a green line. Okay. So this guy will dominate. So iska field will be this way. The direction is which way? Minus I cap.
Yup.
Now, as you keep getting closer and closer and closer, magnitude also will increase. So two things, the direction is left side and the magnitude is increasing. So your graph will increase and blow off to minus infinity. As you get closer and closer to this charge Q, the magnitude will go to infinity, but the direction is on the minus I cap. Is this part clear, everyone? When you're traveling from minus infinity to minus D, the magnitude of the field is increasing because you're getting closer to the charge. And because it is a plus Q charge, it is pushing to the left side. So the direction is minus I cap. Fair enough. Once you cross this plus Q charge, the direction becomes right hand side because the field charge is on the other side. Since you're very close to the infinity, very close to the charge, the value will go from infinity. Now it's a discontinuous function. And as you go towards the center, at the center, both the fields will cancel out. You get a null point. This is your null point. Now, what happens once you cross this point? Once you cross this point, the plus Q charge will start dominating because you're closer to the right side charge. That will dominate. And that field is which way? Left hand side. So as you get closer to this charge, the value again will go to infinity, but this time it is still on the minus I direction. So the graph would become like this. I'm changing the color to show you which one is dominating. The green color indicates the left charge is dominating. The red color indicates the right side charge is dominating. Once you cross this plus Q, the field will be again right hand side. This is how the graph looks. Please check this graph. So if a person is going from minus infinity to plus infinity on the x-axis, so initially here, the field is on the left-hand side, so negative graph, value is going from 0 to infinity. Once you cross this charge, the value is infinity because you're very close, but the direction has become right side. So graph will start from plus infinity and go to 0 in the center. Because both are plus q, they'll cancel out. Once you cross the origin, the right side charge will start dominating. So that field will be stronger than the green charge. So the field will become negative again and will go to again infinity. Then again this thing. Please ask me if you're confused with this. Any step you're not clear, ask me. This is very important. This will come in gravitation, magnetism, idea is the same. So basically this is the field, an observer is moving on the x-axis. These are not field lines, huh? This is not field lines. This is a graph. This is a graph of Ex versus X. All got this? Aryan, Aditya, Neil, Swastika, Utsa, got this? Now, you guys try this. This is plus Q. This is minus Q. D comma 0 minus D comma C. Now you plot the graph. Plot Ex versus X. I showed you for plus and plus. I'm asking for minus and plus.
So can you go to the previous slide for just a minute? Yes, sir, thank you.
Two null points. Nah. Think.
फिर एक प्लस क्यू के राइट पे एक माइनस क्यू के लेफ्ट पे
Nah. You're goofing up. Think. There are no null points in this graph. सोचो ना, to get a null point अगर डायरेक्शन ऑपोजिट तो काफी है क्या?
तो मैग्नीट्यूड तो दोनों का सेम है ना. अच्छा
हाँ,
डिस्टेंस
हाँ.
डिस्टेंस
Uh, so let this guy be minus q. So on the left side field will be this way, on this side the field will be this way. So this graph will go to plus infinity. Once you cross this, there is no null point. Center में they don't cancel, they add up. And outside, the magnitudes can be equal. So once you cross this, if you see this guy is pushing this way, this guy is pushing this way, the field is negative, the graph goes down. Check, this is how the graph looks. Again, like I said, I'm using two colors to indicate who is dominating on which side. Please check the graph. There is no null point. At the center, you'll have a kind of a value, but there's no null point. Mathematically, how did you get a null point?
+4q and -4q में exactly क्या किया था?
क्या किया था? Next वही question है. All got this? हाँ, Saina, how did you get mathematically a null point?
I assumed the distance x to the left of minus q.
तो वही है ना. So in direction, what did you take? Left of minus q, okay, and then?
Yeah. And then kq by x square is equal to kq
Set
by
ही नहीं हो रहा
2d.
है. तो logically सोचा ना. You're saying kq by x square is kq square by x plus d whole square.
2d,
You're
no?
saying
Because it's minus.
2d कहाँ से आएगा?
One is minus d, one is plus
ठीक है
d.
ना, ठीक है. तो x is x plus 2d whole square. Then what did you do?
I solved the quadratic.
Expand it, x square cancel हो जाएगा. You'll not get a quadratic.
But there is one x term. Only the x square cancels, but 4dx remains.
So then what did you get? Then you'll get x is equal to minus
d.
sign. Meaning
Yeah.
that means you're getting on the right hand side. So that is wrong, na? But you assumed it is on the left hand side.
Right. Because my assumption is wrong, it's
Your assumption is wrong. So वो mechanics का logic work नहीं करेगा. Sign will take care of it. Sign won't take care of it here. Because the moment you said on the left hand side, you took the field direction one way. But if you take the middle, you'll take the field direction differently. So if you say it is on the left, you should get the answer on the left only. So that way, that you have to be careful. Try this thing. This is the actual question. Huh? If it is the exam, this is what I will ask you. 4q minus q minus d comma 0 and d comma 0. Plot. Previous graph, if we shift, we'll get this. Nee, previous graph is looking like what? Previous graph is this. This is this. कुछ relation ही नहीं है. Let's get this, everyone. This is a good one. Try. I'll give you 2 minutes. Get it properly. Just give it a try. I'll be just back in a minute. Okay. What did we get? Okay. हाँ null point तो है. Got it. फोटो भेजो देखते हैं. It's
Yes,
an
sir.
interesting graph. Okay, ठीक है ना. Don't worry. If you don't have a phone, once I show you, you can tell me whether you got this thing or not. Double derivative. हाँ. वो तो है अनुष्का. That is what you're saying is right. So maybe you must have got it. Let's see.
I send the photo, sir.
नहीं. Okay, you took on the left hand side. Okay, तो plus Q 4Q reverse लिया क्या?
No, I did that about. एक minute, let me see.
ठीक है ना, चलेगा. Must be right on. See.
I did that.
So let's say, again, I'll just change the colors for you to see who is dominating there. So this is plus. This is minus Q. So here the field is this way, the field is this way, the plus guy is attracting this way and this way. So on the left hand side, the field will go to, from infinity में it is 0. As you get closer, you'll blow off to infinity. So this is how it looks. And once you cross this point, you're getting it. The 4Q will push this way. The minus Q is attracting this way. So the minima will come somewhere this side, I guess. I think it should come somewhere that way only. Minima won't come in the middle. Minima will come somewhere to the more to the right side because this guy value is lesser, na? And then after this point, the plus Q will start dominating now. Exact that point we can calculate. You can use maximum minima and figure it out, but it's okay. We don't need it. This will blow off here to infinity. Once you cross this point, the value is this side. Now something interesting happens here. At this point, it cancels out. This is your null point, which we actually calculated also. I'll just draw it a little close by only. Null point will be closer to the right hand side. Now after this, think about it logically. Matlab, till here minus Q dominated. At this point, what happened? The 4Q and minus Q got cancelled, right? That means if you cross this point, the 4Q will again start dominating.
एक सेकंड सर, एक और बार प्लीज.
Logically सोचो see. Who is strong here? Minus Q or 4Q?
Minus Q.
Minus Q. Here who is strong at null point?
No.
Both are equal. Both are equal. Means once you cross this point, the green started dominating now. Logically ऐसा सोचो ना. If you're very far, then it will be K 4Q by R square. This will be K Q by R square. If we are very far, this denominator won't matter anymore.
Oh, makes sense.
The farther you go, the 4Q will start dominating. At a very far distance, 4Q ka field will be more than plus Q. Is that making sense, everyone?
Yes, sir.
Did you get the graph? So once you cross the null point, 4Q will dominate again. Is that making sense? That is what I was saying. That's what the graph looks nice. So the graph actually goes up and then bumps up to 0 again.
So very far ना, अब आप वहां से
तो very far मतलब यहाँ पे basically calculate किया ना हमने, D calculate किया ना?
That is not very far.
No, I'm just saying very far. So definitely right, but this is 3D comma 0 actually.
हाँ, और
After that point, 4D started dominating 4Q. हाँ रे?
It should be 2D, 0 ना, क्योंकि हमने D पे किया था calculate. So minus.
नहीं है ना, ये ऑलरेडी origin है ना, तो from here it is the distance ना.
हाँ, and that is supposed to be D only, ना?
So D plus 2D, right? Distance between them is 2D ना रे.
Origin
No,
से
then right,
Yeah,
yeah, it's
हाँ.
3D.
Yes, sir, my bad.
समझ में आया ये calculation में what did we do? When the distance between them is D, answer came D ना. If the
हाँ, yes,
distance is 2D, ये 2D आएगा, but इसका coordinate D, 0 तो 3D, 0. Got it? You can calculate if you want, but yeah. But got the point here. Once you cross 3D, I mean logically सोचो ना. When I'm here, minus q is dominating. When you're here, minus q is dominating. When you're here, minus q is dominating. When here both are equal, means what? 4q is becoming stronger, isn't it?
तो physically कैसे stronger और I'm not able to relate much.
Actually, physically stronger मतलब 4q is becoming weaker, but minus q is becoming much weaker much faster.
ठीक है sir, I think.
If you actually try to put a graph na, it's like, let's say example, minus q, right, is if this is 4q ka field, it is decreasing. The minus q is like this. So once you cross this point, right, it is decreasing much faster.
Makes sense.
All clear with this graph? This third question is the most important one. Please check. Clear, no? There's no null point in the center. Aryan, got the catch, right? What happened? Can I go ahead? Next one. Next one. We have a particle, mass m, charge q, projected with speed u, angle theta, gravity is there, and also there is a field also, E naught x. So this point is origin x, 0. Find h max, time of flight, and range. So a charged particle is projected with u theta, mass m, charge q. There is a horizontal electric field, and a vertically gravity is there. And the horizontal electric field is also not constant, it is depending on x coordinate. Means that x is equal to 0, there is no field, but as you go, the field is becoming more and more and more. The range is little mathematically complex, so yeah, you can but try to get the equations. Kushagra, that is right. Others? Right, it's a good one. Kinematics and electrostatics. Right, Ishan. Saina, you got it. Adrit, you're right. Yeah, the first two parts are right. Get the range part. Hmax and time of flight are the easiest ones. How would we know that? That is because you didn't revise the kinematics notes. This question gives, remember? Particle is projected with u and theta. There is a horizontal wind which is creating an acceleration A. And then we wrote a same statement here. The vertical components are not affected by anything that happens in the horizontal direction. The time of flight and the Hmax are independent of horizontal accelerations. If you see the graph also, no matter how much the acceleration is there, all have same Hmax. The ranges will get messed up. So that will be a first statement there. There is no need to solve for H max in this thing. The vertical components are unaffected by horizontal accelerations. Therefore, H max will be u square. If you see the actual formula, it is u y square by 2a via acceleration. So u square sine square theta by 2g. Time of flight is 2u vertical by a vertical 2u sine theta by g. You can't do that, Ray. Vishagra, that is wrong. Socho. When can you use that formula? S is ut plus half at square. When, yeah. For the horizontal part, remember acceleration is not constant. You can't use the three kinematics equations. Let's go. E naught x it is. So x is an x coordinate. The more you travel, the more you have. We did a variable like this, but it's not the same equation. If you remember, we did one very deadly problem in kinematics. Did we do or we didn't do? I think we didn't do it here. No, we didn't do it here. Let's go. Integration, try, I'll give you a minute. Just get me the equation at least. It's okay if you're not able to finish all the integration. Let's see. X tan theta, you can't use any of those things, right? God, all those are derived for constant g. All the kinematics formulas are derived when there's no horizontal acceleration. Now, when you draw the FBD of this particle, what are the forces acting on this? At any instant, there is an mg downward, that is okay. The horizontal force will be charge into field. So the horizontal force Q into A is equal to mass into acceleration. This is Q E naught into X M V X dVx by dx. I'll just write it as V. Integrate this. So you end up with V dV is equal to Q E naught by M X dx. This limits will be horizontal velocity U cos theta to Vx. This is from 0 to X. We get Vx square minus U square cos square theta by 2 is equal to Q E naught X square by 2M. So that gives you Vx is equal to root over Q E naught by M. 2 will cancel X square plus U square cos square theta. Again integrate this thing. So dx by dt, this guy will be root over Q E naught X square by M plus U square cos square theta is equal to dt. This will go from 0 to time of flight. This will go from 0 to range. Now, what we'll do for convenience, let's call this guy as B and let's call this thing as A. So if you have dx by root over ax square plus b integral You can actually remove that A outside. That will be better. I'll do one thing. Dx by root over x square plus mu square cos square theta by QE naught. This guy would be root over QE naught by m integral dt. So you can treat this whole thing as some A. You will learn this in maths. So dx by root over x square plus a square. You can put x is equal to a tan theta. Dx will be a secant square theta. This guy would be a secant square theta by that x square is a tan square theta. So a into 1 plus tan square theta is a secant theta. So we get integral secant theta d theta, which is ln secant theta plus tan theta. That's your integration. We can substitute and finish it off, but it's okay, leave it. It's more of a max form. Integration with substitution. It becomes more complex. If I want to make the problem simple, I should have done the particle is projected vertically with you. That would have made your life easy.
No, but आपने जो integration लिखा that is sec theta का integration.
Yeah.
And but you want under root x square plus a square का ना?
तो अभी आएगा ना, वापस ये x का वैल्यू पे डाल दो.
अच्छा आपने substitute ठीक है.
Getting it? The whole headache, who created all this problem? This guy. This u cos theta created all this problem. If अगर वो u cos theta नहीं होता था ना, your life would have been easy. You would have got v is proportional to x directly. Then it would have been dx by x is equal to dt. You would have got something nice. That u cos theta and the root messed it up. Yeah, you can leave it here. It's okay. It's mostly a max. Clear? If you got till here, you're done with the physics part. Zero is coming in ln n for vertical case. You shouldn't take that only. You'll get actually an exponential, na? Matlab in that case.
सर अब substitute भी करेंगे तो
बहुत difficult है solve करना.
no सर direct है इसका but ये तो नहीं आता.
अरे what is secant theta plus tan theta का differentiation? 1 by secant theta plus tan theta, sec theta secant theta tan theta plus secant square theta.
x.
So cancel हो गया ना वो?
x plus
वही आएगा. Same thing था. Check करो. Clear? Next one.
Sir, if you project it vertically, it won't go forward.
क्यों? Why will not go forward? तो अगर projected
Velocity depends on
vertically,
x.
हाँ, तो we'll get vx square is equal to q e naught x square by m ना?
No, but there is no initial horizontal velocity. So,
But अरे God, but there is a horizontal acceleration ना? So you mean to say if there is no velocity, it will not go only? Means if you drop something,
x is always zero. X is always zero. X equal to.
ठीक है ना? X is equal to x naught से फेंक दे. I got your point. Because x0 तो move ही नहीं करेगा. Then let's project it from somewhere. X is equal to maybe some x naught. Right, Adit? So we have a string here, length L, mass m, charge q, gravity is there. Field 0 हो गया था. True. So now what you did at t0, a horizontal electric field is switched on. Initially it is at rest. First question, find maximum deflection. Matlab find the maximum angle deflected. Find time period for small oscillations at equilibrium. If the system comes to equilibrium, find time period for small oscillations. Let's get this. I hope you understood what I mean by maximum angle deflected. Hey, Saina, you goofed up. I know what you did. That's a trap. You went and jumped into it. Let me ask you this question. Do you think it will stop at mean position?
No.
No. So mean position is not the maximum angle deflected. And you know where we have done this? I think I did this thing for this only. I left it for this chapter only. Yeah. What part energy का question था ये? So this is your pendulum. Let's say it finally comes to stop here, V0. Be careful, it doesn't stop here. We did something like this actually. This is your mean position. You don't stop at mean position, you have maximum speed. So if you try to write the force at mean position, you'll get tan inverse QE by mg. This is angle theta. Remember, the force is EQ. The force is always horizontal. This is L sine theta, and this distance is L into 1 minus cos theta. The work done by external force, change in potential energy plus work done, change in kinetic energy. So this guy will be EQ. The horizontal distance is L sine theta. The work done is force into the displacement in the direction of force. Change in potential energy is mg L 1 minus cos theta. Kinetic energy is 0 because initially rest and finally rest. So we can write this thing as EQ 2 sine theta by 2 cos theta by 2. You know, you'll get double the answer if you remember. Whatever you get the mean portion iska double aana chahiye. And this is 2 sine square theta by 2. Root will cancel. We end up with theta is 2 times tan inverse EQ by mg. Should get double of what you guys got. Now in mean position, the mistake everyone does, right? They balance the forces and they think that is the extreme position. That is a mistake. If I take this angle as alpha, we get tan alpha is equal to EQ by mg. This is your equilibrium position. Now, if you see the direction of the net force here, F net is root over m square g square plus e square q square. This is equal to m into g effective. So what's the time period? Time period for a simple pendulum is 2 pi root over L by g effective. So the pendulum will think this is down, the net force, and this will be the oscillation. Make sense? So you take the net force. Isn't that the direction of what is the meaning of down? Down is nothing but the direction of net force. So if you keep the pendulum at equilibrium, pendulum will think this is down and it will oscillate like this. So the net force will be root over mg square plus eq square. That should be equal to m into g effective. So get g effective from there, dump it in the SHM formula, and then you'll get the answer. Clear with this? So this is work power energy, this is SHM. Be careful, the body does not stop in mean position. क्या था ऐसा क्वेश्चन एक्चुअली हमने work power energy में. Any doubts on this? Is this clear, everyone? Easy? Again, if you see, the only new thing that you learned is what? F is equal to Q into V. After that is all mechanics only. Swastika, Maulika, got this? Clear, na? Ali, Abhinav? Going ahead, next one. We have a solid sphere. Mass M, radius R. You place this on a rough ground. There's no slipping. The entire upper hemisphere is positive charged. Plus Q. And the lower entire hemisphere has a negative charge distribution minus Q. Then at T is equal to 0, you switch on the electric field. Initially at rest. Find alpha, angular acceleration, and a friction as function of theta, where theta is the angle rotated. And describe the motion of the body. Let's get this. It's a solid sphere. The entire upper hemisphere is plus Q, the entire lower hemisphere is minus Q. Figure it out, figure it out. Exam, I won't come and give you the answers. You should remember. This would be a good advanced paragraph question. Electrostatics, center of mass, rotational mechanics. What is the center of mass of solid hemisphere? E power minus 3 by pi.
VR by
Oh. 3R by 8. Don't forget it. I'm just joking. Half disk का center mass कहाँ पे है? Half disk.
3R by 4 pi. 4R by 3 pi.
4R by 3 pi. You almost believed E power minus 3 कहाँ से आएगा रे center of mass में? चलो try. First thing, see, let me teach you a concept. First of all, try to understand when you take a, let's say, an hemisphere. When I ask you where is the gravity acting, what would you say? Where is mg acting? What would you say? Center of mass. But if you actually think about it, the mass mg is acting literally at every point, isn't it? So every point has dmg, 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 and you said due to center of mass, whatever blah 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 concept, we said the weight is taken at center of mass. So we choose mg at center of mass. We actually proved it will come at center of mass, but in reality, the weight is distributed all over in FBDs. But if you see, the weight is not at single place. Weight, every point has some weight. Now, using the same logic, now if you ask Max will say, I don't care what you want to call it. You are calling E and M and all. If you look at the field now, so every point will have a field E into dq, E into dq, E into dq. Now, if you see the same logic there, M ka place mein Q is there, G ka place mein E is there. Then from the same logic, we can also say that force EQ will act on the center of mass. Now, people call it center of charge, but technically there is no concept called center of charge. The only reason it is working is because it's a linear function, isn't it? F is equal to QE. It's a linear function, so it works out. Getting it? So we can see by symmetry, because if a Max doesn't care what you want to call it, E or M or Q, it will simply say, boss, you're just changing symbols. Mathematically, they look the same. We can see by symmetry, the electric force EQ acts at the center of mass. That is an important concept. Remember, this is a very useful concept. It works when the charge distribution is uniform. I could have taken a disk also. If I give a non-uniform charge distribution, then literally I have to find center of mass actually. So you could still work it out, but let's keep it simple. Valid for uniform charge distribution. If you see a shape with the uniform charge distribution, without thinking, you can put the charge at center of mass and solve. So now what we do, let the sphere rotate by an angle theta. So I'm going to replace all the charge here at the center of mass. This guy would be EQ, and this distance is 3r by 8. That is the center of mass of a solid hemisphere. So if you rotate, even that thing will rotate. Whereas this charge is negative charge, so the force will be EQ. That is again a distance of 3r by 8. Remember, this is a couple. And the torque due to a couple is independent of axis. And remember, there is a friction, don't forget that. Because the ground is rough, there is a friction waiting also for you. Normal reaction and sphere ka own weight. So these are all the forces. This guy is accelerating, this guy is alpha. Our favorite point is A at the bottom. So if you take torque about A, mg ka torque 0, F ka torque 0, N ka torque 0. This guy would be, and let this angle be theta and theta. That would be 2 times EQ 3r by 8 sine theta is equal to I about A into alpha. So 3 EQR sine theta by 4 IA solid sphere to 7 by 5 MR square alpha. Alpha is 15 EQ by 28. Simplify नहीं हो रहा है ना, नहीं हो रहा है. MR sine theta. If you see this, cos आएगा ना, perpendicular distance. I was just testing you guys. And Utsa has passed the test. So cos theta. If you see here, perpendicular ना, ठीक है. Yeah,
We
it's
can
almost that thing. हाँ
We
रे
can't solve it from the center of mass by taking.
कर सकते हो, but then friction का torque पता नहीं है ना.
Okay.
Then A
I
is equal to, yeah, you will get it. बस एक extra equation आएगा, you'll get it.
actually got the wrong.
Torque is independent. अरे go and check it out ना. If you have two equal and opposite forces, you take torque about any axis, you'll get the same torque. Normally, if you take a force, right, the torque will depend on which axis you're taking. A is equal to R alpha. From there, you got acceleration also. Friction कैसा आएगा? F is equal to ma. There's only one horizontal force. So mr alpha. There you get the friction also.
The distances won't be different of this one and this one.
इसका which one?
That first DQ and the second DQ, both of them are different distances from that axis.
But अरे IB value just हो जाएगा ना रे. You'll take ICOM, I'll take IA. You're talking about the torque, yeah?
Yes.
So if you take torque about the center, friction का torque होगा FR and EQ का torque होगा ना. EQ का torque will still remain same. That doesn't matter.
Whatever axis it
So
remains.
what do you mean it doesn't matter? Yeah. Like,
if you have two equal and opposite forces, you choose any axis, the torque is always F into D.
okay, I didn't know that.
Oh yeah, gods, you all forgot rotation में क्या रे? You are not there, but others.
I got the answer actually.
देखो, torque due to equal and opposite sides. Torque is F into due to any force. Torque due to couple. It doesn't depend on the axis. It is always you can write F into torque about any axis is this. You can take a random point and calculate करके देखो ना. You'll get the same answer. अरे, you're saying something? So friction आ गया ना? So you got everything. Abhi, how does the motion look like? This is actually an oscillatory motion. What else did I ask you? I can ask you one more question actually. Find maximum omega. So how will the motion look like here? So initially the sphere is here. This was the +1. So I'll just shade it. This guy is the plus. Then it will be like this. Then it will be like this. This is your mean position basically. At this point, the torque becomes 0. This is your mean position. Torque is 0. Then you will become like this. And then finally you'll become like this. You'll become completely inverted. So at this point, the angular velocity is 0. At this point, the angular velocity is 0. You're getting how it is rotating. It goes forward, makes a complete thing and comes back. Why does it come back? So Shona, once you come here, how is the field now? This is negative now. So this force will be EQ. This force will be EQ. Now alpha has become this way, isn't it? You're getting how is the torque? Here the torque is like this. So it is rotating this way. Here it is rotating this way. So the ball will simply keep rotating front and back like this at the same position, little front and back. Able to visualize how is it? So basically, once you cross this point, the torque is like this. So at this point, if you see now, EQ is this way. EQ is this way. So alpha is this way. At this point now, EQ and EQ, they will cancel out. So torque is 0. At this point, right, EQ is this way and EQ is this way. So this thing will start rotating backward. So this is an oscillatory motion. This is not an SHM. Periodic motion and oscillatory motion. And at this instant, omega max, you have maximum angular velocity when you rotate by 90 degrees. So in this case, theta is 90 degrees. And alpha ka value we derived here. Alpha is proportional to the cos theta. 15 EQ by 28 MR cos theta. Alpha you can write as omega d omega by d theta. 15 EQ by 28 MR cos theta d theta integral. This will go from 0 to omega max and this will go from 0 to 90. Solve here and you'll get omega max from here. So I can ask you that also. Find the maximum angular velocity of the ball. Clear with this? Or they can ask like this also. If the system is in equilibrium, find the time period for small oscillations. Then क्या करेंगे? We'll put it in equilibrium. Then we'll displace by small angle theta and we do that. Torque is equal to I alpha. And they can play like this also. Find the condition it does not slip. So friction should be less than or equal to mu mg. So from there I can find the mu ka value also. This is the minimum coefficient of friction for not slipping. I can ask a lot of things. The moment I wrote this concept, right, the force can be written as EQ. This is the center of mass concept. Once I wrote EQ, this is electrostatics. Torque is rotational mechanics. Friction is less than friction ka chapter. This is oscillatory motion. There, you can bring anything you want. Clear with this?
To decide if it is oscillatory motion, we need to analyze the motion, or we can directly get from the equations also.
Equations आ रहे हैं ना, देखो ना, alpha cos theta, when theta goes from 0 to 90, alpha is positive, 90 to 180 it is negative, तो alpha reverse हो गया ना. Mathematically you'll get it, but visualization is the best thing. Clear? So with that, we're done with the field. So the next part will be electric potential and potential energy. We'll be doing that in the next class. So like I said, next week we are on a break. So we'll be directly catching up again on 15th. Right? So we'll continue then. So then we will go like, we'll finish off field and potential, and then we'll do for all continuous bodies, field due to solid sphere, ring, rods, and all. That is the most important part. Okay, so with that, we'll wrap up for the day. So have a great vacation, and I'll see you guys on May 15th again. Please do revise a bit and come. Don't come and say, like, sir, we have seen you somewhere. So does happen. Give a break for 1 week and people don't remember you anymore. So, okay, so with that, we'll wrap up for the day. So any doubts, anything, stay back and ask, or else you're free to leave.